The number of protons in the nucleus tells us which type of atom we have. But to understand the atom's chemical behavior, we have to look at the electrons. And we know with our latest model of the atom that electrons don't randomly fly around the nucleus. Instead, they occupy specific regions within the electron cloud called orbitals. These orbitals can get quite complicated, but they can be simplified with electron shells or energy levels. In this model, electrons are arranged in shells at fixed distances from the nucleus. Electrons in the first shell, closest to the nucleus, have the lowest energy. The energy increases with increasing distance from the nucleus. Electrons always occupy the lowest energy level available before filling the next one further out. The first shell, with the lowest energy, holds up to 2 electrons. The second shell holds up to 8 electrons. The third shell can hold up to 18 electrons, but only holds 8 as the outermost shell. And the fourth shell can hold 32 electrons, but only holds 18 as the outermost shell. Each of these shells are getting filled in different periods in the periodic table. Elements in period 1 are filling the first electron shell. Elements in period 2 are filling the second electron shell. And elements in period 3 are filling the third electron shell. We can see these energy shells filling as we move along the elements in the periodic table. The simplest element, hydrogen, atomic number 1, has 1 proton and 1 electron. This single electron occupies the lowest energy level, nearest the nucleus. The next element, helium, atomic number 2, has 1 more proton and so 1 more electron. And so helium's 2 electrons will complete the first shell. Lithium, atomic number 3, has its third electron occupying the next shell further out. We write the number of electrons per shell as 2, 1, and we call this the electron arrangement. Remember that the second shell holds up to 8 electrons. So the next 7 elements in period 2 will continue to fill this shell. Beryllium 2, 2, boron 2, 3, carbon 2, 4, nitrogen 2, 5, oxygen 2, 6, and fluorine 2, 7. At this point, the second shell can only hold 1 more electron. Neon completes this shell with its 10 electrons arranged 2, 8. Sodium, with 11 electrons, requires a third shell for its last electron, giving an arrangement of 2, 8, 1. Remember that the third shell holds up to 8 electrons as the outermost shell, so the next 7 elements in period 3 will continue to fill this shell. Magnesium 2, 8, 2, aluminium 2, 8, 3, silicon 2, 8, 4, phosphorus 2, 8, 5, sulfur 2, 8, 6, and chlorine 2, 8, 7. Argon completes the set of 8 electrons in the third shell with arrangement 2, 8, 8. The next element, potassium, will use a 4th electron shell for its last electron, giving an arrangement of 2, 8, 8, 1. Finally, calcium, atomic number 20, has its 20 electrons in the arrangement 2, 8, 8, 2. This is usually as far as we go with the electron shell model. After calcium, the third shell continues to fill with more electrons, up to a maximum of 18. But we'll use a different model to represent these electron arrangements more accurately. So in this video, we've looked at how electrons can be arranged in electron shells around the nucleus. We've seen that the energy of these shells increases as we get further from the nucleus. And we've looked at the electron arrangements of the first 20 elements in the periodic table.